Hello everyone, welcome back to this channel. If you are new here, subscribe and buckle up because today onwards we are diving deep into the absolute core, how Python understands and executes your instructions. Ever wondered how Python performs calculations, making decisions, or follows a sequence of commands? Well, it all comes down understanding the following concepts: operators, operands, statements, expressions, and precedence of operators in an expression. These all are building blocks of every single Python code that you will ever write, no matter how simple or complex they are. So, grasping this all will help you or empower you to write cleaner, efficient, and more predictable Python code. Let's jump to it. Defining what operators. Now let us define what operators and operands. Operators are nothing but special symbols or keywords like addition, subtraction, multiplication, or keywords such as and or is not, in, and much more. These symbols or keywords are useful to perform operations involving these operators on some values or variables, in which these values or variables are called operands. In this simple example, 20 plus 14 is nothing but an expression. Expression is a collection of literal variables, functions, or the like. So 20 plus 14 is an expression in which 20 and 14 are the operands, where 20 and 14 are operands, whereas this symbol is operator. Right? So simply you can understand these operators and operands with this simple expression. This is called addition operator. In general, we do have a number of operators or class of operators, as we can see here: arithmetic operator, assignment operator, comparison operator, logical identity, membership operators, where the last four evaluated to true or false. So under arithmetic operators, we do have a number of operators too, such as addition, subtraction, division, modulus, fuller divisions. So this example is one of these arithmetic operators, in particular addition operator, which adds two numbers. In this context, 20 plus 14, where these two numbers are operands, whereas the symbol plus is known as operator. So if we take the multiplication of these two numbers are the operands in this expression, whereas this star, which is a multiplication operator. The other thing is the modulus. Modulus computes the remainder after division, right? 4 by 3. This is nothing but modulus expression, which is expected to produce 1, right? So this symbol is operator in this context. 4 and 3 are the operands, and 3 exponentiate to 4 is nothing but 3 to the power of 4, where this as the operator, 3 and 4 are the operands. The same is true 4 by 3. This is nothing but two forwarding slashes that divides and rounds down to the nearest integer, right? These all collectively are called arithmetic operators. What the other operators are assignment operators and comparison operators. Assignment operators include this token equals token in mathematics, which is called assignment token in Python programming language. Right? This is useful to assign a number from the right side to the left side. That is not to say x is equals to 5, for example. It is not right communication to say x is equal to 5, but that is 5 is assigned to x, or x equals to 5. So this example is called assignment statement or assignment operator due to the assignment token. The other are this one plus this equal sign, this minus this one, product this multiplication operator with this, and the division with equal with assignment, this modulus with this one. These all are assignment operators which are useful to perform the operation and update the variable. For example, in updating variable from its initial value, for example, if initially x was 5, x can be updated by x plus 3. Now x is updated by incrementing x by adding 3 to x, right? Now the value x, the new value of x is 8, right? So this is equivalent also x plus 3. This one and this one are equal in communication, right? The another assignment operators are comparison operators. Now we are coming to the equality, not equality, greater than, less than, and extra comparison operators. Now to compare two values, we make use of this double equal signs or double assignment signs, right? To check two values, x is equal y, we are asking whether x is equal with y, or x is not equal with y, we are asking whether x is not equal with y or not. No. But if x is greater than y, or x is greater than y, or x is less than or equals to y, x is greater than y. These all are nothing but comparison operators, right? Tests if two values are equal, not equal, or either of the two values are greater or less to each other. These all are nothing but comparison operators. Now let us proceed to the next logical operators. These logical operators are keywords such as and, or, not. These all are nothing but logical operators. If two values are connected with AND keyword, returns true if both statements are true, or two values returns to true, false otherwise, right? If one of the two statements is false, the whole expression evaluated to false if the expression is connected by AND. Otherwise, if the two statements are connected using a or, that expression connected using or returns true if at least one statement is true, right? This expression connected using or is turned into false if both statements are false. Now let us proceed to not. Not is nothing but inverting the original result of certain variable, right? If x was true from the scratch, if we preceded by not, that x turns to false, right? So let us see some examples related to this one. For example, x is true, y is false, let's say. So let's run this one. So x and y, print this x and y evaluated to is a true or false. This logical operators evaluated to either true or false. So what we ask implicitly is x and y is true or not? Yes. In this context, x is true and y is false. Therefore, this expression is nothing but true and false. So this turns, as a rule of thumb, false, because two values or two statements connected using AND turns to true if both are true, right? Print x or y. This is true because one is true from these two values. This turns to true. The other thing, what this yields, not x. Not x now is false because the original value of x was true. Not is useful to invert the original value of a variable. So the original value of variable x was true. So due to the not keyword, inverted to false now. This is false. Now let us see this statement also somewhat complex. What will be the result of this? What will be the result of this one? For example, we do have two statements to left and to the right of AND. This x is greater than 0. Wow, where is that x is? Nothing but this one. Let x is 5, for example. Now x is expected to be 5. Now let us check whether this whole expression turns to false or true. Now let us check one by one. First, let us evaluate this one. X is greater than 0. Yes, 5 is greater than 0. This is true. And let us evaluate this one. X is less than 10. Yes, 5 is less than 10. So true and true, this evaluates to true, right? But if this one, x is equals to 10. Now this expression, whole expression, is connected using AND. So this result turns to true, but this one is false. Then true and false turns to false. This is false, right? The same is true. Check this one. Now let us proceed to identity operator. Identity operator are nothing but either is or is not. Alright? We can make use of one of these operators. It compares memory locations of objects, whether they are referring to the same location or not. Alright? For example, if we execute this assignment statements A banana, B refers to banana 2, right? Then we know that A and B refers to a string, with the letters banana, but we don't know yet whether they point to the same string. So identity operators checks whether A and B are referring to the same object, right? As we can see from this figure, these A and B are the references or variables. A is referring to banana. Banana is the value of the object. Now B is referring to banana 2. So A and B referring to two different strings but the same value. So this language can easily convert it into this one. A and B are referring to the same object, which is banana. A and B referring to the same object. So if this banana is assigned to two references, Python checks whether these two names refer to the same object using is operator. Now the is operator will return true if the two references are to the same object. In other words, the references are the same, meaning the location is the same. The location can be checked by ID. If the ID of the location of each reference is equal, the two references are equal to. This equality can be checked by the is operator. Now check this one. Print A is B. True. This is checked or turned to true because the ID of A is this one, ID of B is also this one. This is the same, right? You can check. Print ID of A, ID of B, true, right? So what Python checks, if the ID of a reference of A is equal with the ID of the reference of B is equal, now the two reference or variables refers to the same object or the same value. So these things, it's nothing but identity operators. Membership operators also evaluated to either true or false, through, in, not in, right? The in operator tests if one string is a substring of another. For example, print B in banana. Yes, B is in banana string. So this expression turns true, right? True. What if this statement is made some change? Banana B is Bn in banana is a question. Bn is the substring. Does this substring, which in particular Bn, is in banana? Yes, we can check. No, we don't have this Bn as a part of this banana string. So turns to back in false. Let us check this one. Apple. Print is apple is app in apple. Apple, yes, true. This is a part. This AP is here as a part of this one. Therefore, what this operator in operator checks whether substring is or whether a string is a substring of another string. Not is nothing but the invert of that, right? If I make this one, for example, not in, if I make this not in, right, this false will be true. Yes. So let us come to end by solving this one challenge. What that challenge is this one. What will be the result of this one? Print. What the result of this expression is nothing but recalling the precedence. No. No. Okay, let me give you some highlights about statements and expressions. These are not beyond these two operators and operands, but to give some highlights, statements are nothing but any instructions that the Python interpreter can execute. Right? A statement is an instruction that the Python interpreter can execute. Example, assignment statement is a statement which assigns a value from the right to the left side, such as is all things x is equals to 5 is an assignment statement. Control flow statements is nothing but a statement which is preceded by while, for, if, and etc. Import statements are nothing but statements which are useful to import modules or libraries. Right? These all are statements. Any statement in Python that the Python interpreter can execute is known as a statement. Expression is nothing but a combination of literals, variable names, operators, function calls. Right? Any call that we written here around or are expressions. Right? Expression need to be evaluated to produce a result such as a value or object. Right? But the expression can appear on the right hand side of assignment statements. It is obvious. If assignment statement is there, it is always appear in the right hand side. So what's the important thing that we proceed to understand here is order of operations. In an expression there are a number of operators, a number of operands are there, a number of inputs are there as a value, variable, or functions, function calls. So how do they operate? Which comes first, which comes later? Needs rule or order of operations. So these rules of operations are called rules of precedence. In understanding of Python communications, Python understands the same precedence rules for its mathematical operations as mathematics does, such as PODMAS, PDMAS, and extra. Right? So, stemming from that understanding, Python takes into effect. So, as usual, parentheses have the highest precedence and allows us to control the order of evaluation. If there is an expression in a parenthesis in our expression, that should be evaluated first. If there is exponentiation in our expression, that exponentiation will take the highest precedence next to parenthesis. So the highest one is parenthesis, the next one is exponentiation. Right? If you compare the multiplication and division with subtraction and addition, yes, multiplication and division should come first compared to the addition and subtraction. What if operators having the same precedence, such as addition and subtraction, right, which should come first, is nothing but there is a rule also. We shall see later. So let us see some examples related to these precedences. For example, let us consider this one. 2 times in parentheses 3 minus 1 was the result of this one, based on the rule of precedence in mathematics. Because Python takes into effect from the rule of mathematics. Yes, mathematics can also do the expression under parentheses first, which is 3 minus 1 is 2. 2 times 2 is 4. So for this evaluates to 4, not to 5, because the expression under the parentheses should evaluate first. Therefore this one is 4. Right? Let us minimize this one. Yes, this one should be minimized. Right, what about this one? 1 plus 1 in parentheses, let us see this one. This should be evaluated to 8, because first we have to evaluate this one. 1 plus 1, 2, 2 exponentiated to 5 minus 2. Before exponentiation, we have to evaluate this, because parentheses have highest precedence than the exponentiation. Therefore, first we evaluate 1 plus 1, which is 2, then 5 minus 2, which is 5 minus 2, which is 3, 5 minus 2, 5 minus 2, which is 3. Therefore, this one is 2, this one is 3. Then to exponentiate to 3 is 8, right? Invalid syntax. Why? Why it is invalid is 8, right? The same is true. This one. What about this one? 5, right? 5 minus 2 times 2, right? We know that multiplication precedes subtraction, so we have to multiply 2 by 2 first, which is 4. 5 minus 4 is nothing but 1, right? Which is 1. What about this one? 3, this one, right? Exponentiation comes first, relative with regarding to or compared to multiplication, right? So 1 exponential to 3 is 1. 1 times 3 is 3. Therefore, this is nothing but 3, no, 3, 1 exponential to 3 is 3, right? This one. What about this one? 2 times 3 minus 1, right? It's similar to this one. So this should be evaluated first. 2 times 3, 6 minus 1, 5, right? Should be first. The next one is about the same precedence in exponentiation in an expression. Left associative, meaning that evaluating from left to right. If we have the same precedence in our expression, we have to evaluate them from left to right. For example, if we consider this one, 6 minus 3 plus 2, we should come first. We don't know, but as a rule of thumb, we follow left associative rule, meaning that from left to right, because addition and subtraction have the same precedence in an expression. Therefore, as a rule of thumb, we evaluate first this one. 6 minus 3 is 3, 3 plus 2, 5, right? This is using left associative rule, right? What about if exponentiating, successive exponentiating is that? For example, here, what will be the result of this one? Right? 2 exponentiate to 3, then 3 to 2. We should, does this comes first or this one? This is nothing but based on this right associative. In exponentiation there is an exception, right? We evaluate right to left. First we evaluate the rightmost, which is this one, then we evaluate next, meaning that this one becomes 2 exponentiating to 9. This is nothing but 5, 12. 3 exponentiating to 2 is 9. To the power of 9 is this one, right? Therefore, let us do this one together. What will be the result of this expression? What will be the result of this one? This one. This whole expression consists in number of operators and operands. So what we need to do is we need to evaluate the expression in an parenthesis first. This one should be evaluated first. Even within this parenthesis there is a trick. This addition and subtraction have the same precedence. So we follow the left associative. First we add these 2 plus 3, then we minus 1, meaning that 4, right? Then we come up with this result, 4. Then here exponentiation proceeds to division and the other addition and subtraction. Then we stick around here for the time being. From this one, two successive exponentiations, we first evaluate the rightmost exponentiating this one as a rule of thumb. Therefore, we come up with this result. Copy, right, 8 as to the power of 3 is 8. Then the same is true now. This also evaluated first because exponential proceeds to the addition and subtraction. Therefore, this becomes what? 256. Now 256 divided by 4 plus 3 minus 1, right? So compared to division to the addition and subtraction, this division should come first, right? This division should come first. Therefore, wow, this 6, 4, this one. Then now let us turn back to the left associative. Subtraction and addition have the same precedence. Therefore, we first evaluate this one, then we add this one. Therefore, this becomes 2 plus 64.0. This one 66. Therefore, if we evaluate this one as it is, this should give the same result 66. This one. Thank you for your stay with me.